Are you sure that it was an asteroid that caused the extinction of dinosaurs? There's this huge drama about why these horrifying creatures disappeared. It's a big deal in both science and movies. But what really happened to the dinos? How do scientists figure it out? And why does it even matter? Let's see. Let's take a trip back to England in 1842. There was a scientist named Sir Richard Owen. He was checking out some huge reptile fossils and noticed that 3 of them, Megalosaurus, Iguanodon, and Hylaeosaurus, had a lot in common. So he had this light bulb moment and decided to combine all these creatures into Dinosauria, which means terrible lizards in Greek. The scientists were studying dinosaurs and grouping them based on their looks. But then Charles Darwin showed up and gave even a better idea. Turns out, species don't just appear out of thin air, they evolve. And now, everyone had to rethink how they were defining dinosaurs. They came up with a new idea called phylogenetic classification. Picture a big family tree with all creatures ever. Somewhere up there, we find Megalosaurus and Iguanodon, and we say all dino descendants come from their common ancestor. It's like tracing back your family tree, and if we go far enough, we find the ultimate dino ancestor. Sounds like a plan. But then, things got a bit complicated. When we talk about dinos, we've got the ones with feathers and beaks and the ones without. That's when we found out that birds are cousins to certain dinosaurs, maybe even evolved from them. After learning that, scientists had to look at the bird family tree and rethink the dino definition. In the end, they decided that birds are kinda dinosaurs, but not exactly. Confusing, huh? But in any case, now we have 2 groups. The first one is birds, and the other one is non-avian dinosaurs, which are extinct. That means now we have to reconsider our question. Instead of asking what caused the extinction of dinosaurs, it should be what caused the extinction of non-good dinos. The answer might seem simple. People often think of a gigantic space rock as the dino destroyer. It's probably the first thing that pops into your mind. Even Google and other search engines agree on this one, like best friends copying each other's homework. History teaches us that about 66 million years ago, dinosaurs totally vanished, except for the ones that became birds. Of course, the truth is more complicated. And not all dinos vanished in one go. Some went the natural way, and there were many extinctions here and there during their time on Earth. But the big event we're talking about looks like a movie scene change. Like suddenly changing the channel on a TV. One poof. And the Earth went from the time of dinosaurs to the time of mammals. Scientists call these time periods the Cretaceous and Paleogen. We even give this special event a nickname, the KPG, or KT extinction. Some even refer to it as the 65 million years ago event, even though the more correct number is 66 million years ago. We've got 2 main theories in the spotlight: asteroids crashing and volcanoes erupting like crazy. Let's talk about the asteroid idea. So, around 66 million years back, imagine a humongous asteroid smacking into Earth. This thing was about 6 miles wide, about as big as Mount Everest. It zoomed through the sky super fast, like a mountain going 100 times the speed of sound. And when it hit, it released a ton of energy. It crashed down in what's now southern Mexico, near a spot that's tied to the dinosaur extinction story, Chicxulub Crater. Everything close to the impact was zapped into vapor in a snap. Picture the biggest energy burst in ages, like 1 billion years or more. Nothing near the crash site stood a chance. Next, there was the aftershock. As the fireball cooled down, the Earth's surface went bonkers. The ground twisted and shook, causing unimaginable earthquakes. The continents became huge, bouncy castles. And then, the stuff that got blasted up by the impact came raining back down like a rainstorm. Even if you weren't near the huge pieces falling in Mexico, you'd get hit by these smaller, super hot bits flying through the air. This made the air so toasty that forests burst into flames all around the world. Are you ready for more? Time for a massive tsunami. The ocean floor got all churned up, pushing waves inland around the Gulf of Mexico. But just imagine, even all that wasn't enough to destroy all the dinosaurs. For example, dinos in New Zealand were pretty fine, but we know that they all went extinct. So what happened to them? They felt a little rumble, and suddenly, the sky started getting all dark and gloomy, as if it was nighttime. And hold up, what's that? A blanket of ash is slowly creeping around the whole planet. Now, here's where the real drama happens. The big problem with the asteroid crash wasn't the instant boom you might think. It's all about the long-term effects. Imagine the stuff that got blasted up into the sky blocking the sunlight. Days turn into nights, and temperatures drop very sharply. A lot of plant-eating dinosaurs passed away, and hunters were having a great feast, but not for too long. Without sunshine, the food chain falls apart very quickly. Then, the ash falls back to Earth, things go from bad to worse. Other nasty stuff starts floating around in the air like carbon dioxide. This carbon dioxide mixed with shattered seafloor bits makes the temperature go wild. The Earth was playing hot and cold all at once. That's when somewhere between 50 and 80% of dinosaurs said goodbye forever. What's even more sad is that this number only counts the species themselves. If we look at the number of individual animal lives lost, it's even higher. You might think that at least the poor mammals finally got their chance after the dinos left. But even mammals had a tough time. We are very lucky that a few brave mammals managed to survive this crazy chaos. The ones who made it were like the little champs with speedy energy systems, flexible diets, or secret hideouts. But this story is only one hypothesis. Next, we have the volcanism hypothesis. Volcanoes. These fiery mountains are used to spitting out molten rock and causing epic destruction. But surprisingly, this theory isn't about explosive eruptions. Nope. It's about something sneakier and slower. Around 1 million years before the Dino Doom, there's this big change happening under the Earth's surface. Way below where India's floating, a rock river starts forming, heating things up. And then, India gets hit hard. It turns into a sea of lava, like a fiery ocean. It's like a gazillion of dump trucks filled with lava slowly pouring out. These solidified leftovers are known as the Deccan Traps, like a super deep layer of hard lava covering a piece of land the size of France. And just like in our asteroid story, the real trouble comes from the air. For hundreds of thousands of years, sulfur dioxide spread like an unstoppable shadow. It was making the sky gloomy and the rain toxic. Food sources turned into poison, and oceans became acid baths. And then, carbon dioxide took the stage. It was like a temperature button, flipping the Earth's climate upside down. It was a roller coaster of chaos. The ecosystems were stressed, food chains snapped, and species waved goodbye one by one. Both theories seemed pretty realistic. All the experts were having a big debate about which theory was correct and why the dinos disappeared. So, what is the real answer? Unfortunately, we don't know. Some scientists support one theory, some support the other one, and we're left scratching our heads. But hey, don't be too hard on the media or the scientists. They're all doing their best to figure out the mystery of the dinosaurs' disappearance. And maybe one day, we'll finally learn the real answer. So, stay tuned.
Let's go with the widely accepted theory that a massive asteroid hitting our planet wiped out the dinosaurs. It does make you wonder why mammals made it, though. One idea is that mammals were better prepared. Back then, they weren't the most popular creatures on Earth, but they were pretty diverse. They bred themselves into a huge range of species, and it might have saved them. Some said mammals survived because they were smaller, so they needed fewer resources. As they had to constantly hide from dinosaurs, they managed to survive in difficult environments, way before the hit. But let's say the asteroid never came, and it never damaged the environment the dinosaurs thrived in. It's safe to say our fauna would look different today. Take the mighty Titanosaur. It's considered the biggest land animal to ever exist, some reaching lengths of about 7 standard cars lined up. It had a neck so long that it would have needed a 2-story home just to fit. It also had a plant-based diet, so it ate from the ground, but from very tall trees too. There was nothing much left to eat for, say, the little Jeremiah, a mammal that lived roughly at the same time, but was as small as a popsicle stick. Let's take this thought experiment a bit further and imagine we have a time machine that could transport today's mammals to the time of the dinosaurs. Some scientists say they have gotten bigger, so there's a chance they could survive, right? They're also much more evolved in terms of their diets and skills. Others say definitely not. They couldn't survive, mostly because they're too small to compete with dinosaurs. An adult T-Rex was just about the size of a bus. It probably wouldn't waste its time trying to capture food that's human-sized, for instance. They'd probably be on the lookout for prey the size of a car, or even bigger, like an elephant. And it most likely wouldn't take them long to win the fight. Sure, a T-Rex might munch on something smaller too, but only if it's really hungry and has no other alternative. If we had no choice but to send some mammals back in hopes they could survive, what would be our best bet? Some say the chimpanzee could be a good candidate, as these primates build their sleeping nests higher up in trees. This might have kept them safe from the carnivore dinosaurs living on land. There's no real evidence of dinosaurs being able to fly, but we do know there might have been some reptiles that took to the sky for transportation, like pterosaurs, the flying lizard. These ones like to eat fish and smaller animals, but who's to say they wouldn't pick up a chimpanzee given the opportunity? Another good candidate might be the hyena. Today, the spotted hyena is the most common big carnivore in Africa, and it's highly adaptable. They could snatch up all sorts of prey by themselves or even in larger units. They can digest most parts of their prey, including the skin and bones. These animals aren't picky eaters, and they wouldn't mind chewing on parts that other creatures would gladly skip on. Not to mention, they'll eat fruits too, if needed. Hyenas are overall healthy and sturdy animals, with some studies showing they hardly ever get health problems. But like any other animal on this planet, the hyenas also have their weaknesses. We still don't know why these creatures can't be found in Europe anymore. But some research suggests they found it hard to coexist with humans and wolves. Also, they're not very adapted to living in forests. Orcas might have been able to rub elbows with the dinosaurs too. These creatures also don't have any natural predators, which earned them the nickname the wolves of the sea. That's because they go out looking for prey the same way wolves do, in groups. Orcas may be related to dolphins, but we can hardly call them friendly, as there have been cases of them sinking ships on purpose. They're highly intelligent animals that spend time together and are very organized. They also do this thing where they often take down more prey than they're prepared to eat. It may be because they see this experience as training. Other theories suggest orcas are so intelligent that they look for food in advance, even though they're not hungry yet. It might also be because whenever they want something to munch on, they're looking for the best quality food there is. The reason why they might not survive in the dinosaur era, though, is the global temperature. Back in the Mesozoic era, our planet was seriously hotter, several degrees warmer than it is today. Orcas prefer living in colder waters, but you'll find them in all oceans and most seas. Ostriches are the no-brainer answer. Look at them. They're practically dinosaurs. They even have a long-lost dino cousin that lived in the Cretaceous era, called the Struthiomimus. Its name translates to ostrich-like, because of its similar powerful and speedy legs, agility, and even feathers. On the downside, they might not be able to take down larger dinosaurs. The vegetation back in the Mesozoic era would have been different too. Conifers used to dominate land, and ostriches are known to be pretty picky eaters, so they might have had a difficult time finding food back then. There are plenty of reasons to send felines through that time machine too. In the Jurassic period, for example, there were plenty of slow-moving prey to eat and tons of hiding spots in the thick bushes. Felines are sneaky animals, have precise vision, and are extremely good at climbing. Some pack a punch for their size, making them fierce fighters. Lions are good contenders because of their speed and teamwork. They might be able to take down some decent-sized dinosaurs, like the Europasaurus, when working together. Leopards are really good at climbing trees, so they could snatch prey and enjoy it above the ground, where they might be safe from bigger predators. What might be their downfall is again the temperature difference. It was considerably hotter back then. Today's large mammals aren't equipped to deal with that extreme heat. Lions might be the kings of the savannah now, but it would be too hot even for them. If they ever want to grab a spiky-tailed herbivore for lunch like the Tugiangosaurus or Stegosaurus, they might be in for a surprise. One hit from their extremely powerful tail could cause some serious damage. Not to mention run-ins with raptors like the frightening Saurophaganics. The single most likely animal that might survive being roommates with the dinosaurs is the platypus. This quirky Aussie creature is one of those rare egg-laying mammals. It's a fan of freshwater and as close to a living relic as an animal can be. Scientists were able to trace its origin back as far as 120 million years ago. For food, it wields its sensitive beak to catch shrimp and worms underwater. When it dives, skin flaps cover its eyes and ears, so it becomes blind and deaf. But it still uses that beak like a high-tech radar. A grown platypus can even feast on half its body weight in a single night. Scientists have known for a while it shares many traits with reptiles, like its shoulder bones or the fact that it lays eggs. Other creatures that coexisted with the dinosaurs still exist today, just not mammals. Snakes made their way into our fauna in those prehistoric times too, as well as cockroaches and bees. Some species of sharks are even considered to predate the dinosaurs. And if we look at our entire planetary history, we'll see they survived 4 out of 5 periods of mass extinction. Horseshoe crabs have the nickname living fossils because their evolution was much slower than any other animal that we know of. Not because they're not smart, but simply because they found their perfect form much sooner. So they didn't need to make a lot of changes. They have a very rudimentary immune system, but it seems to work wonders. No wonder they stayed pretty much the same for over 400 million years. There's a monster hiding in the remote forests, swamps, and rivers of the Congo Basin in Central Africa. It has a long neck, looks like a dinosaur, and is the size of an elephant, or maybe a hippo at least. That's what people who claim to have seen it say. It should have gone extinct millions of years ago, but this Congo's version of the Loch Ness Monster somehow survived. This creature is the Mokele-Mbembe, which means one who stops the flow of rivers, and more folks are saying they've seen it lately. European explorers first heard the stories of this creature from the people living near the Congo River in the early 1900s. A German captain even included a description of the monster in his official report from his expedition. The locals told him the animal was of a brownish-gray color with smooth skin, a very flexible neck, and only one long tooth that could be a horn. Some of them mentioned a long, muscular tail, like that of an alligator. They also said that the creature lived in the caves, but climbed the shores even in the daytime to find some plants to eat. Locals also believed its favorite snack was a kind of liana with large white blossoms. Some of them even showed the German captain some fresh path the monster left leading next to those plants. And oh, They warned him that Mokele-Mbembe definitely didn't like humans and took down any canoe that would sail nearby. Dinosaurs were a real hit in pop culture in the 1910s, and several newspapers in Europe and North America wrote about the dino-like monster from Africa back then. In the later years, several expeditions traveled to the Congo Basin to search for Mokele-Mbembe or interview claimed witnesses. They did not find any direct physical evidence, but collected many stories. One zoologist in the 1980s said he took a film of Mokele-Mbembe, but the footage did not develop properly. Stories and movies like Jurassic Park have kept the dream alive that dinosaurs might still be hiding somewhere in deep forests. At some point, people stopped reporting sightings of the creature as often, so it almost became a forgotten legend. But it all changed recently, as many people claim to have witnessed the mythical monster with their own eyes. Cryptozoologists, those fans of mysterious creatures, believe it could be a dinosaur that, for some reason, didn't go extinct, related to a brachiosaurus or a diplodocus. This idea comes from how people describe seeing the creature, with a super long neck, a huge body, and a tiny head. They think it might have stayed hidden in the deep forests of Africa all this time. But scientists say that if it really were the last living dinosaur, we would have found some real proof by now, like a photo or bones or something showing it walking around the Congo Basin. Some expeditions that are trying to find proof the monster is real have even used sonar technology to scan the murky waters of Central African rivers and lakes in search of any large, unidentified creatures. Some people even narrowed down the monster's location to a specific remote lake, surrounded by untouched jungle in the swamps. So far, the search for evidence hasn't been successful. The explanation behind all the sightings of the Mokele-Mbembe could be the changing ecosystem. More and more human settlements are moving into the huge Congo Basin rainforest. People aren't used to seeing large animals that live in the forest, so they believe they have witnessed the mysterious creature from their folklore. The human brain often fills in the gaps in something we don't know and uses imagination to explain it, especially if there's a ready-made version that everyone's heard of. But still, we can't completely rule out the possibility that there are some new, unknown species of animals hiding in the Congo forests. Maybe just not a missing dinosaur. Another legend, this time Mongolian, says there's a giant worm living deep in the Gobi Desert. Yep, similar to the monster you've seen in Dune. The creature, which is supposedly up to 6 feet long, can spit acid that could melt anything and shoot electricity. They say it spends most of its days hiding underneath the sandy dunes, but likes to come out during the wetter months of June and July. The people in the West first found out about the megaworm of the Gobi Desert thanks to an American paleontologist, Roy Chapman Andrews. This brave man was probably the inspiration for Indiana Jones. In 1926, he wrote about the creature in his book. At the meeting with Mongolian leaders, Andrews heard detailed descriptions of the creature, even though none of them had ever seen it themselves. One of them said it looked like a sausage that was about 2 feet long, with no head or legs. According to him, the worm was so poisonous that just touching it could instantly take your life, and it lived in the loneliest parts of the Gobi Desert. Andrews didn't think the creature was real, but he shared these stories again in another book. And then, stories of the monster spread around the world. In some of them, it's only 1 foot long. In others, it's as large as a human. Some say it looks like a snake, and some describe it as a caterpillar. Some people claim it has wings and can fly, and others think it could be a supernatural evil being without a body. The color of the creature also remains a subject of debate. It could be white-gray, brown, or even bright red. The stories of witnesses are probably so different because the creature doesn't even exist. In 1983, one scientist who was visiting the region heard that an old man had managed to finally catch the mysterious worm. He also found out there was a nest nearby and decided to risk it all and see it. But instead of a scary monster, there was a tartar sand boa inside. Luckily for the scientist, this snake is non-venomous, but it does have gray-brown scales and could match the description of the giant worm. When he showed it to the locals, supposedly, all of them said it was the monster they had seen. Big expeditions from America, Britain, and New Zealand came to the Gobi Desert to try and find the creature. Many other adventurers came from all around the world on their own, but found no evidence the monster was real. But many Mongolians are sure the death worm is no fantasy. If you don't believe there's a monster in the Gobi Desert, how about one in Lake Worth in Texas? According to local folklore, there's a part human, part goat creature with scales and long clawed fingers hiding there. It all started back in July 1969, when locals claimed to have spotted this mysterious creature roaming around. The newspapers loved the story and started reporting about new sightings. One article said that the monster jumped out of a tree and landed on some guy's car. Another report claimed that the Lake Worth monster decided to throw an automobile tire at a group of people. Someone even managed to take a photo of the creature, and the newspapers published it. Locals started flocking to the lake at night, hoping to catch a glimpse of the creature, but no one could find any evidence it was real after all. The author of the monster's photograph later said it was most likely someone's prank, because the creature really wanted to be seen. Then, a reporter from the local newspaper received an anonymous letter saying that it was 3 high school students who decided to dress up and scare people. Even despite this, some cryptozoologists think it could have been an undiscovered primate species that walks on 2 legs. We don't know if the Worth monster is real, but it does one good thing and brings together the local community. Every year since 2009, they throw the Lake Worth Monster Bash.
Billions of years ago, our whole solar system was nothing but a big cloud of dust and gas floating in space. Then, something happened to disturb that cloud, but scientists still aren't sure what exactly it was. It could have been a distant star that turned into a supernova with a bang that caused the dust cloud to start spinning. As it spun faster, the dust and gas got pulled into the center and created a thick, spinning disk called a solar nebula. The gravity at the center became so strong that hydrogen atoms started crashing into each other, producing helium and a lot of energy. As a result of all these space shenanigans, we got our sun about 4.6 billion years ago. This process used up more than 99% of the dust and gas in the big cloud. The leftover stuff started to come together to make different shapes. The cloud kept spinning, and bits of matter bumped into each other and stuck together. Some of these clumps got big enough to have their own gravity, which pulled even more matter to them. This is how the planets, including our Earth, were made. You wouldn't recognize our planet though, as it was nothing like we know and love it today. It was hot, and I'm not talking about perfect beach weather hot. It was scorching hot, as it was mostly made of magma, which is basically melted rock. Just imagine how hot it should be to make the stones melt. After a few 100 million years, Earth started to cool down. As the planet changed and its outer crust started to form, there were lots of volcanic eruptions. These volcanoes released water vapor, ammonia, and carbon dioxide into the air around the planet. Slowly, oceans started to form from the water vapor. The planet was every introvert's dream back then, with not a single living being around until the day when the first simple life forms began to appear and live in the new oceans. Those tiny organisms were single-celled microbes that gave birth to all future lives, including yours. They left signs in rocks that are about 3.7 billion years old. The signs were a type of carbon molecule made by living things. Then, at least 2.4 billion years ago, cyanobacteria evolved. These were the first organisms to make food using water and the sun's energy, and they released oxygen. This caused a big increase in oxygen, which made it hard for other microbes that couldn't handle oxygen to survive. Then, tiny microbes started living inside other tiny microbes. This way, they were forming organelles, small structures inside a cell with a specific function. One important organelle is called mitochondria, and it helps turn food into energy. For the first time, DNA got packed inside a part of the cell called the nucleus. These new complex cells, called eukaryotic cells, had different parts that each did a special job to help the whole cell work better. Soon enough, the earliest animals would rule the world. But don't get your hopes up. They weren't fluffy kittens. All the changes on Earth were happening against the background of the supercontinent Rodinia, which formed around 1.2 billion years ago. It pulled together almost all of Earth's land masses into one gigantic piece of land. It was surrounded by a massive ocean, so the whole planet looked like a giant land and sea puzzle. Unlike the green, lively continents we have now, Rodinia was barren and rocky, with no plants or animals on land. So, early life forms like algae thrived in the ocean. The breakup of Rodinia caused changes in Earth's climate and ocean currents. New coastlines and environments eventually helped diversify life on Earth. Cells began living together and finally evolved into the first animals around 800 million years ago. Sponges, and I don't mean the loofah you use to shower, were some of the earliest animals. By around 580 million years ago, they had neighbors, including fronds, ribbons, and quilts. But then, another 40 million years later, which is like a minute in evolutionary time, the conditions changed. Oxygen levels rose, and the first animals were replaced by new life forms. It was the beginning of the Cambrian period, the time of the giant shrimps and other creatures you'd rather never meet. Those invertebrates that ruled the planet looked so weird and not Earth-like that it took scientists years to realize these scary creatures were actually the ancestors of modern mollusks and crustaceans. Meet Hallucigenia, a creature with 7 or 8 pairs of spindly legs, the same number of paired spikes coming from its back, and a head you won't tell from its tail. Another cool creature from that period was the abnormal shrimp. Unlike most animals back then that were tiny, it was over 3 feet from head to tail. There was also the Weewaxia, that looked sort of like a stegosaurus, but without a head, a tail, or any legs. It looks like these creatures were born without defensive spikes and grew them as they got older. If they ran a beauty contest in the Cambrian period, Aishia would likely win. It had many common features with today's tardigrades. Although it was just 1 or 2 inches long, it was the nightmare of prehistoric sponges, and it clung to them with its multiple claws. We still have some live souvenirs from the Ordovician period living among us. Take lampreys, for example. The marine life kept flourishing. There were squid-like nautiloids with tentacles and a special shell with gas-filled chambers that made them float in the water. They swam well by squirting water out of their bodies and used their tentacles to catch prey. Another group of sea hunters was the conodonts with their tiny fossil teeth. The few complete fossils we have found show that they looked like eels with big eyes to spot their food. Fish back then were small, with mouths that pointed downward, which helped them suck up food from the ocean floor. Lampreys and hagfish are their living relatives today. The hard-bodied arthropods, like early relatives of crabs and spiders, started exploring life on land. They moved into freshwater and shallow lagoons, and one type of these creatures was the horseshoe crab. Even though they're called crabs, they're actually more like spiders and scorpions. Around this time, the first simple plants also began to grow on land. But a surprise ice age interrupted their plans. Most of the world's land at that time came together to make a huge supercontinent called Gondwana. It included what is now Africa, South America, Antarctica, and Australia. Another supercontinent called Laurentia included what would become North America. Gondwana drifted south until it settled at the North Pole. Huge glaciers started forming over what is now Africa. This led to a 20 million year ice age and a huge extinction. At least half of all marine species were wiped out around 443 million years ago. The landscape wasn't looking too cozy, but have no worries, the first plants were about to hit the land. As temperatures rose and sea levels climbed again, the oceans began to recover during the Silurian period. Huge reef systems grew in the warm, clear tropical seas. You can still see remnants of these ancient reefs today. They are limestone rocks. The oceans were full of tiny creatures called plankton. At the top of the food chain were these terrifying sea scorpions. Some of these sea scorpions grew to over 6 feet long, and they were the largest arthropods ever. They looked like giant scorpions with huge, compound eyes to spot their prey, the primitive fish. They caught it with their strong, claw-like pinchers. Speaking of fish, they were starting to change and found new ways to eat, not just by sucking up food from the ocean floor. A group of spiny sharks developed jaws which made their mouths more dangerous. Even though these jawed fish weren't very big during this time, they were becoming better hunters and would later become top predators. On land, the first tiny, creepy crawlies began to show up. They were primitive centipedes and early ancestors of spiders. The first plants on land didn't have leaves, but they could stand up straight, thanks to their stiff stems. They also had special tubes inside them to move water and nutrients around, just like how our veins move blood. Mosses and other small plants soon followed and helped create a better environment for animals to start living on land too. The climate was nice and warm. The supercontinent Gondwana was still near the South Pole, but the big ice sheets from before melted away. Plants continued to grow and change during the Devonian period, but you'd probably be more impressed by a millipede as long as a car. If you visited the Earth back then, you'd wander in the first big forests made up of lycophytes, horsetails, and ferns. By the end of this period, the first successful trees appeared. They could grow really tall, up to 98 feet, about half as tall as the Leaning Tower of Pisa, and had thick trunks about 3 feet wide. They didn't have real leaves but had fern-like parts growing right on their branches and used spores to reproduce. The insects of that time were pretty wild. One of them was a huge dragonfly with wings as wide as a big pizza. This giant dragonfly lived in open places where it had room to fly, and its big eyes helped it spot its food, smaller bugs. It used its spiky legs to grab the insects it wanted to eat. Another monster from that time had wings about 22 inches wide and a mouth that looked like a beak. On the ground, the biggest bug ever known on Earth was wandering wild and free. It was a millipede as long as a car that likely ate fruits and seeds. The insect grew into such giants thanks to the extra oxygen in the air, up to 35% instead of the usual 21%. They could easily breathe even when they were huge, and there were no big birds to eat them, so they could grow really big and explore land and sky with nothing to worry about. But not for long. Fish started changing into the first animals that could live on land. These early fish had special fins that worked like arms and legs, and they could explore new, swampy areas where there were lots of plants and no big predators. One of the oldest animals that show this change mostly lived in shallow water, where it walked on the bottom. It had a head that looked like a crocodile's, and it could move its neck and breathe air through its nostrils. It grew up to 10 feet long. Its back fins were bigger and stronger than the front ones, which helped it move on land. At the end of the Devonian period, Earth went through 2 long extinction periods when up to 70% of sea creatures disappeared. But the plants and animals living on land mostly survived these tough, cold times. It also had a cool, distant cousin, coelacanth. This fish was almost 5 feet long and had 4 fins that looked like limbs, but it never moved to land. It adapted to life in deep water, hiding in caves during the day and hunting at night. This deep-sea lifestyle probably helped coelacanth survive 4 of Earth's major mass extinctions. For a long time, people thought it was extinct until one was found off the coast of South Africa in 1938. So yep, it still lives in the deep parts of the Indian Ocean. During the late Paleozoic era, animals including a crazy mix of a polar bear and a saber-toothed cat got all independent and didn't have to live near the water anymore. They started laying eggs on land. Fish were becoming more different from each other, and trilobites were starting to disappear. New plants called conifers were growing, and 2 new types of animals also appeared. There were marine reptiles like early lizards and snakes and archosaurs, which later turned into crocodiles, dinosaurs, and birds. This period is sometimes called the Age of the Cockroaches, because an early kind of cockroach was lurking all over the world. But there was something way cooler than a cockroach, like a mix of a polar bear and a saber-toothed cat. It was an early relative of today's mammals with long legs that helped it run fast. It had sharp, saber-like teeth that could slice through the necks of huge plant-eating animals, but it used its teeth to rip big chunks of meat rather than chew. Scientists aren't sure if it had scales like its older relatives or fur like its mammal cousins, but they found hints of ancient poop that smaller relatives had hair, so this guy probably did too. There was also a big reptile that lived in the cold deserts of Eurasia. Imagine a creature as big and heavy as a black rhino, weighing about 2,400 pounds and stretching around 10 feet from head to tail. It was covered in thick, bumpy plates all over its body, which helped protect it from predators. Because it was so heavy and slow, it couldn't run fast, so these tough plates were its best defense. To stay so big and strong, Scutosaurus had to eat a lot of food all the time. It was one of the first big plant-eating animals to live on Earth. These animals were like early versions of big dinosaurs that came later. Even though Scutosaurus looked a lot like those dinosaurs, it was not closely related to them, kind of like how we're not closely related to whales and dolphins. The closest living relative to Scutosaurus is the tortoise, another slow-moving armored reptile. When you look at this guy, Dimetrodon, the first thing you notice is the big sail on its back that could remind you of some dinosaurs, but it was actually more closely related to us. It was a proto-mammal and had some unique features, especially in its skull. It had a small hole behind its eyes where jaw muscles attached, which is something dinosaurs didn't have. Dimetrodon also had different types of teeth for different uses, unlike dinosaurs that had rows of the same kind of teeth. The sail on its back was probably used to show off and attract mates, or scare away rivals. The last period of the Paleozoic, called the Permian, ended with the largest mass extinction on Earth ever. It wiped out more than 90% of all the species on the planet. The 2 big landmasses named Euramerica and Gondwana joined together to form one huge supercontinent called Pangaea. Around Pangaea was a giant ocean. Because Pangaea was so big, the middle of it was probably very dry, since rain clouds couldn't travel far enough to bring water to the interior. This made Pangaea's center a very dry place. The Permian extinction left room for new creatures to thrive. One of them was this guy, looking like a real-life Nessie from Scotland. It was a 20-foot-long reptile with a super long neck, even longer than its body and tail combined. And nope, it wasn't a dino yet, but a protosaurus that lived during the Middle Triassic period, which was just before the time of the first dinosaurs. Scientists used to think it was too heavy on top to walk on land because of its long neck, but newer studies show that most of its weight was centered around its body, so it could walk just fine. Between 240 million and 230 million years ago, a new successful group of animals started to rule the world. They managed to evolve from mostly dog and horse-sized creatures into the biggest monsters that ever existed on Earth. Scientists say they managed to do it thanks to some massive volcanic events. But it's a topic for another video. Life during and after the dinosaurs.
If dinosaurs once ruled the Earth, it seems like we should stumble upon their bones everywhere. But we don't. Why is that? Aren't you curious? There's no conspiracy here. The truth is that the quest to find dino remains is much more complex than meets the eye. Yes, dinosaur bones are real, we found tons of them, and they've already been uncovered on every continent, despite many people arguing otherwise. And the uneven distribution of these prehistoric treasures is simply a quirk of nature. Turns out fossilization is an incredibly rare phenomenon. It only happens under specific conditions. When a dino bites the dust, the journey to fossilization begins. The carcass needs swift burial by sediment, followed by layers upon layers, creating a geological pressure cooker. Minerals sneak into the bones, morphing them into stone. This unique recipe predominantly occurs underwater, where sediments like sand and mud can gracefully cloak the fallen giants. Which is why dinos meeting their end above ground rarely end up as fossils. For example, we barely find any fossils of species who lived in the jungle, and especially in the mountains. Researchers reveal that many fossils arise from areas near lakes or rivers. Whether drowned before a flood or carried away by rain, these dinosaurs lucked out in fossil formation. These are the reasons why we don't discover dinos in every nook and cranny. The harsh reality is that we might never meet many dino species, all because of these limitations of fossilization. Around 71% of dinosaurs will never be discovered. We don't even know how many species we've lost due to unsuitable conditions. If we're super lucky, we might find some fossils of mountain dinosaurs in local rivers, but that's a very rare case. So yes, while dinosaurs graced the globe, all the fossils we found so far were due to great luck. Now, this makes you wonder how much dinosaurs lived in general. There are myths about them leading a tortoise-paced life. People believe that dinos were sauntering through centuries to achieve colossal sizes. Funny enough, the truth is exactly opposite. In reality, dinosaurs lived shortly and shone bright like rock stars. Unfortunately, once these animals hit the prime of reproduction, they often found themselves on the fast track to fossilization before reaching their full-size potential. What's interesting is that dinosaur life cycles align with the rhythm of trees. Perhaps you know that it's possible to determine how old the tree lived by its rings. It's true, each pair of light and dark rings equals 1 year of age. Like the rings tell us about trees, dinos' bones tell us about them. Researchers examine slices of bones under a microscope, analyzing different tissues to gauge growth rates. Thick rings mean rapid growth, and narrow ones mean a more leisurely pace. In the animal kingdom, bigger usually equals longer life. So, some people wonder whether big dinos actually live longer. Apparently so. Large sauropod dinosaurs, akin to ancient behemoths, likely took around 30 to 35 years to reach their colossal peak. Following that, they might have enjoyed a few more decades on the prehistoric stage. For smaller dinosaurs, like the nimble arthropods, life was a swift affair. They grew to their full size after around 4 to 5 years of life. But after a mere 3 to 4 years, these mini dinos, unless super fortunate, might have bid adieu. So it turns out many dinosaurs didn't live for hundreds of years. Most of them, even colossal ones, rarely marked even their 50s. It's a surprise if you compare them to today's giants like blue whales and elephants. These animals boast human life-like spans. Blue whales live for around 80 to 90 years, and many elephants make it to their 60s to 70s. And they're not as big as some dinosaurs. Yeah, it's a pity that they left our planet so early, and we don't have a chance to study so many of them. What's even sadder is that dinosaurs have been doomed from the beginning. Even if a random cosmic rock hadn't hit our planet, dinosaurs would still have gone extinct by today. The Chicxulub meteorite smashed into our planet 66 million years ago. For the record, it didn't actually destroy all the dinosaurs, only the non-avian ones. The rest became birds. Yep, some of these colossal creatures became tiny chickens and pigeons we see today. Guess they know what wolves might feel like. But even before that happened, the Earth was slowly preparing a catastrophe for them. Recent research shows that the era before the asteroid impact wasn't exactly a paradise. It was more like a brewing cauldron of environmental challenges. The scientists delved into the Deccan Traps, one of the largest volcanic regions in present-day West India. They came up with an innovative technique to study the past through volcanoes by measuring sulfur concentrations in rocks. That's how they learned that the Deccan Traps, spewing millions of cubic miles of molten rock, contributed to global climate shifts. Over 100,000 years before the infamous Chicxulub meteor struck, global temperatures might have plummeted by several degrees. This sudden drop was most likely triggered by sulfur emissions from the Deccan Traps. And this, in turn, led to pretty wild, unpleasant climate conditions. The Earth ended up experiencing volcanic winters. This made life super challenging for flora and fauna and set the stage for the eventual dinosaur extinction. So, even if there was no asteroid, dinos wouldn't survive for too long. For a long time, scientists have been arguing whether it was the asteroid that wiped out the dinosaurs or the volcanic activity. Finally, technology is developing, and we can use it to answer this question. An AI system developed by researchers offers its own perspective. Using over 100 processors fed with geological and climatic data, the AI explored the fossil records and over 300,000 possible scenarios to find the truth. And, according to the machine, the volcanic theory is far more plausible. It told the scientists that the climate changes required for a mass extinction were likely caused by the Deccan Traps alone, even without the asteroid impact. The volcanic eruptions coincided with the Cretaceous-Paleogene boundary, starting 300,000 years before the asteroid, and it continued for an extended period. This raised some questions about human versus AI judgment. Some scientists expressed skepticism and talked about the AI's potential bias. But the researchers who led the project are excited about the novelty of their method and its potential to explore other periods of Earth history. However, it will likely take some time for humans to build trust in AI. We already mentioned that non-avian dinosaurs survived this apocalyptic event. For some reason, neither volcanoes nor an asteroid wiped out everything on our planet. Many animals survived, evolving into mammals, and many plants continued to flourish. Plants went through this even better than animals, actually. A catastrophe bid farewell to about 75% of Earth's species, not to count all the individual losses. Yet, botanical wonders survived. Around 78% of our plant species owe their existence to their persistent ancestors. Unfortunately, plants don't turn into fossils as easily as animals do, and we already know that this process isn't quick or common either. So the researchers had to turn to evolutionary trees. They analyzed up to 73,000 surviving plant species. The findings revealed a remarkable narrative of evolution and dominance. Turns out, after the Great Extinction, these sneaky plants seized the opportunity, just like mammals who rose to prominence after the dinosaur era. Major orders, like those of mint, magnolia, and orchids, not only coexisted with dinosaurs, but thrived beyond the extinction. The secret to their success lies in how they could adapt for pollination. They didn't care whether they were pollinated by wind or insects or anything else, basically eating resources from anywhere they could find. Thanks to this awesome adaptability, which scientists call flower power, their legacy lives and flourishes today. Now, dinosaurs ruled our planet for over 165 million years, and some walk on our planet even today. Well, at least some of their descendants. Our modern birds evolved from what used to be a scary group of meat-eating dinosaurs we know as theropods. It all started during the Mesozoic era, about 250 million years ago, when a group of creatures called dinosaurs roamed Earth. They didn't look like those dinos that might have come to your mind, like Brontosaurus or T-Rex, but that's the group dinosaurs evolved from. These creatures walked on all fours and were as big as house cats. They didn't look as friendly, though, considering they were more like weird lizards with long, thin limbs. As you'd expect, this group wasn't exactly at the top of the food chain, but they were really fast and agile, which helped them survive. Over time, they adapted and started walking upright, so their legs were under their bodies instead of out to their sides. And over time, dinosaurs started growing long tails and bigger leg muscles. Their necks became stronger to support the new position they were in, and they even got extra hip bones that helped them move faster and more efficiently. That's when dinosaurs came on the scene, somewhere between 240 and 230 million years ago. Their name comes from the word dinosauria, which means terrible lizard. The oldest dinosaur fossils belong to these fellas that lived in Argentina. This one is even older, but we're still not sure if it's a real dinosaur or its relative, dinosaur morph. Now, considering the size of their ancestors, dinosaurs weren't large at the beginning, more like dogs or horses. There weren't many species back then, so if you could go back to that time, you'd see a bunch of reptiles walking around on two legs. But as time went by, they adjusted to different environments, and we got more interesting groups. For example, small and fast predators, like this guy. They all fall into the category of archosaurs, a group that also includes pterosaurs. Yup, their name may not imply it, but these are not dinosaurs. As some dinosaur morphs evolved into dinosaurs, they got certain advantages, like arms. They could do much more thanks to that. Some could catch prey using their hands, others could grasp branches. Now, the freedom they got by moving their arms later helped some of them evolve into birds and start flying. Dinosaurs were probably warm-blooded. It means they could stay active all the time. They didn't depend on the conditions around them like, for example, reptiles do. The latter are cold-blooded, and they have to rely on their surroundings to regulate their body temperature. Dinosaurs didn't rule the animal kingdom for the first tens of millions of years of their existence either. Crocs were at the top of the food chain back then. Then the Jurassic period hit, and new kinds of dinosaurs showed up, like those giant plant-eating dinosaurs, for example, sauropods. You know them, dinos with long tails and necks that could eat plants at different heights, such as Brachiosaurus. Allosaurus is another famous dino from that time you will probably recognize. Spikes on the tail, bony plates on the back, you know, good old Stegosaurus. The Jurassic period was that time when dinosaurs started to get bigger and bigger. Then the Cretaceous period came along, and finally, these magnificent beasts reached the peak of their fame. That was the time when the mighty T-Rex took the throne and got to the top of the food chain. T-Rex probably lived around 28 years, but it reached adult size really fast. Now, it wasn't easy to survive back then. T-Rex falls into the category of tyrannosaurs, and scientists have found out those fellas were fierce even when they were at a pretty young age. They discovered a fossil of a teenage tyrannosaur that was 75 million years old, and it had two baby dinosaurs inside its stomach. They realized that when tyrannosaurs were at a young age, they went for small dinosaurs, such as these guys, their dino cousins. As they grew older, they started taking on bigger challenges, like those peaceful giant dinosaurs that like to hang out with their group and eat plants. But large predators weren't the only ones that would have made you shiver with fear. That was also the time when fast and smart creatures called velociraptors show up. They weren't some scaly dinosaurs that would catch their prey using those claws in the shape of sickles, like shown in the movies. Their bodies were covered in feathers, and they would grow up to 100 pounds, which is about the size of a wolf. And to bust one more myth, they didn't hunt in packs. Velociraptors probably prefer to hunt solo and use their claws not to slash their prey, but to clutch it. T-Rex and Velociraptor fall into the group called theropods. We mentioned them at the beginning, the creatures today's birds evolved from. But even though Velociraptors were covered with feathers, they still couldn't fly. Their wishbones weren't shaped in a way to support flying, and their arms were too short. Maybe it was better that way because during the Cretaceous period, flying dinosaurs called pterodons were the ones that took over the skies. Things had been going really great for dinosaurs until one unfortunate day 66 million years ago when an asteroid hit our planet. It's not that the asteroid itself erased all the dinosaurs right away, but it caused changes in the environment, which made it way harder to survive. At that time, about 75% of animals living on our planet went extinct. The asteroid was really big. When it hit Earth, it created a giant crater in the Yucatan Peninsula and sent a lot of debris into the atmosphere, which blocked the sun right away. For months, dense clouds of dust blocked sunlight. Our home planet was darker and colder than before, which wasn't good for plants. Creatures that ate plants couldn't survive those changes either. So it all turned into a chain reaction when most of the ecosystem collapsed. When the dust finally cleared, all those greenhouse gases that had formed after the impact made temperatures go way higher than they had been in a really short period of time. All land animals that weighed more than 55 pounds were gone. But not everything disappeared. There were fewer plants, but they were less affected than animals, all because their pollen and seeds can survive really messed up conditions for a longer time. So, what we have today is basically the seeds we were left with back then. After the asteroid hit, flowering plants dominated our planet. All non-bird dinosaurs went extinct too. Some species survived as birds. At first, those brave survivors were small, but later, birds evolved to bigger sizes. Now, there's a study that says that if the asteroid had slammed into some other spot on Earth, the fate of many creatures and plants would have been very different. If the rock had fallen maybe a couple of minutes later, it would have hit deeper waters. Less rock would have vaporized and risen to block out the warmth and light coming from the sun. In that scenario, we'd probably still have dinosaurs around. For example, Triceratops was one of the last dinos that had nothing in common with birds. If the asteroid had missed our planet, we would see some of them still roaming around, but since evolution never rests, maybe in a little bit different form.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, The rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dinos' bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocus or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66-million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, But dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier.